Let's go ahead with the part 2 of this video series. To begin with, there are 4 expansions that you need to learn. Now, based on these expansions, we will be deriving a lot of formulae in trigonometry. The derivations of these expansions are not something that I'm covering in this video. These are expansions. I simply want you to remember them just like standard results. Of course, I will be verifying them for you and I will be showing it to you that these are correct expansions, these are correct formulae, and only after I verify them for you, then we will be going ahead with the derivations which are to come later on. There are derivations for these expansions, you can check them out by yourself, but like I said in this video, we are simply going to memorize the derivations for these 4 expressions that you see in front of you. So the very first one, sine of a plus b. If you want to expand that, you write it as sine a cos b plus cos a sine b. Sine, cos, cos, sine, that's how it goes. A very common mistake done at very early stages. Sine a cos b plus cos b sine a. Cos b sine a is the same as the first term only. So carefully check how you are writing the second term. It is sine a cos b. If you are taking sine a, then next term you take cos a. If you are taking cos b, then you take sine b here. So it is sine a cos b plus cos a sine b. A का अगर sin आएगा तो B का cos आएगा. Sin a cos b plus cos a sin b. How to derive the second formula? From the very first formula itself, what you do is you replace b with minus b. So sin of a plus minus b will make it sin of a minus b. If you are replacing b with minus b on the left, you replace b with minus b on the right hand side also. So on the right hand side it will be sin a into cos of minus b, but cos of minus b we have learned it in the previous video, this is cos b. So sin a cos b plus cos a into sin of minus b. Sin of minus b is minus sin b, so we will write it as minus sin b, and that minus will make the plus over here as minus. So if it is sin of a minus b, it is sin a cos b minus cos a sin b. If you check it carefully, it is the same as the expansion of this. But because there is a minus sign here, there is a minus sign here. If there is a plus in the middle, there is a plus in the middle. That's how you expand the bracket of sine. How to expand the bracket of cos? Cos is literally the opposite of sine. If the sine expansion contains sine cos cos sine, the cos expansion will contain cos cos sine sine. That is, the cosines will appear together and the sines will appear together. So this will be cos a into cos b, and like I said, cos is literally the enemy of sine. It is the opposite of sine, and that is why what did sine do? Sine said that if there's a plus in the middle here, I will have a plus in the middle here also. If I have a minus here, then I will give you a minus in the middle. So cos said exactly the opposite of it. Cos tells you that if there's a plus in the middle, then I will give you a minus in the middle when I get expanded. So this cos a plus b will be written as cos a cos b minus the last two terms being sin a sin b. Look at the fourth expression. Even this is cos, so it will behave opposite to what sin used to behave. This will be cos a cos b plus, because there's a minus here, there will be a plus here. So cos a cos b plus sin a sin b. Initially for a day or two it might be a little difficult to remember them, to memorize them, but with practice within a day or two you will be very fluent with all these formulae, and once you are fluent with that, you can easily apply them even without thinking much about them. But initially for the first 1 or 2 days, just try to derive them, derive in the sense, just try to recollect them in your mind the way we have discussed them in this video. Going ahead with the fifth formula. The fifth formula is for tan of a plus b. This is something we can derive, but ultimately this is also an expansion that you ultimately have to memorize. You can write it as sine of a plus b upon cos of a plus b, because that was ultimately the definition of tan. What is sine of a plus b? We just learned sine a cos b plus cos a sin b. In the denominator, it's cos of a plus b. Cos of a plus b can be written as cos a cos b. plus sine A sine B. I'm so sorry. Cos of A plus B can be written as cos A cos B minus sine A sine B. Now divide the numerator and denominator with cos A cos B. Why are we doing that? It's because, think about it, if you are dividing with cos, you will get cos in the denominator. We already have sine terms everywhere in the expression. Sine upon cos will give us tan, and we will get the expansion of tan A plus B entirely in terms of tan A and tan B. So divide the numerator and denominator with cos A cos B. So we will have sine A cos B plus cos A sine B, the whole divided by cos A cos B, and then in the denominator we will have cos A cos B plus sine A sine B. I'm so sorry, I made that mistake again. Cos A cos B minus sine A sine B upon cos A cos B. When you separate the two terms in the numerator, you will have cos A cos B in the denominator of the first term. Cos B gets cancelled, and sine A upon cos A can be written as tan A. So the first term in the numerator becomes tan A, plus there was a cos A cos B in the denominator of this as well. Cos A gets cancelled. Sine B upon cos B will be equal to tan B. So the second term here becomes equal to tan B, and the numerator ultimately is tan A plus tan B, the whole divided by. Now if you check the denominator and separate the terms in the denominator, the first term will be cos A cos B upon cos A cos B, which is simply equal to 1. So 1 is the first term in the denominator, and the second term will be sine A cos B, sine A sine B upon cos A cos B. Now sine A upon cos A is tan A, and sine B upon cos B is tan B. So we have minus tan A tan B as the last two terms. So the denominator finally is this 1 minus the last two terms which we just got as tan A into tan B. And yeah, that's the final expansion of tan of A plus B. In a similar way, you can try expanding tan of A minus B. And the expansion, the simplification, the derivation, whatever you call it, the final formula for tan of A minus B will turn out to be tan A minus tan B upon 1 plus tan A tan B. Now how to remember this? There's a simple method for remembering this. If there is a plus in the middle with tan, then while expanding, the numerator will have plus and the denominator will have minus. So tan of A plus B will be tan A plus tan B. If there's a plus in the numerator, there will be a minus in the denominator. So it will be 1 minus tan A tan B. If I ask you tan of A minus B, because there's a minus here, the expansion would be tan A minus tan B upon, if there's a minus here, then the denominator will have plus. So upon you will have 1 plus tan A tan B. That's how you can remember the formula for tan A plus B as well as tan A minus B. There's one simple modification or one simple rearrangement that you should know with these two formulae. What if in that formula of tan A plus B, what if in that formula I take B as x and I take A as 45 degrees? Then expanding this will give me tan A, which is tan 45, plus tan B, which is tan x, divided by 1 minus tan 45 into tan x. Tan 45 is equal to 1. So we have 1 plus tan x, and tan 45 we just said it is 1. So 1 into tan x will be tan x only. So we will have 1 plus tan x upon 1 minus tan x. So tan 45 plus x is basically 1 plus tan x upon 1 minus tan x. This is an important, call it result, call it simplification, call it whatever you want, but this is an important rearrangement that you should be able to do by yourself. Like whenever you see 1 plus tan x upon 1 minus tan x, it should hit in your mind, it should click in your mind that this will be equal to tan of 45 plus x. Now in a similar way, what if I ask you tan 45 minus x? In that case, you will put A as 45 here and B as x here. So that will give you tan 45 minus tan x upon 1 plus tan 45 into tan x. Putting tan 45 as 1, you will see that this becomes 1 minus tan x upon 1 plus tan x. The two formulae are very identical to each other. In fact, they are identical to one more simplification that you are going to come across in this series of videos. But for the time being, just take a look at these two expressions very carefully and remember them as standard trigonometry formula only, because very frequently we will be using these simplifications in our sums. So ultimately 1 plus tan x upon 1 minus tan x. We just saw with the derivation that this will be tan 45 plus x, and 1 minus tan x upon 1 plus tan x will be tan of 45 minus x. Let's go ahead with two more modifications, and this time the modification or the formula that we are looking at is for an expression of the type sine a plus b into sine of a minus b. You might be wondering that this is like a plus b into a minus b, so the expansion should be of the type a square minus b square. It is almost identical, but it's not exactly that. So to simplify this, we will use the expansion for sine a plus b. We just saw it is sine a cos b plus cos a sine b. In a similar way, sine of a minus b will be sine a cos b minus cos a sine b. Now if you think over it, this expression is of the type a plus b into a minus b, the expansion for which is a square minus b square. So if we expand this, we will have sine square a cos square b minus the square of b, that is cos square a, cos square a into sine square b. This entire result that we are deriving, or the expression that we are deriving, is for sine a plus b into sine a minus b. We will try keeping it entirely in terms of sine. So to keep the full thing in terms of sine, we will prefer to write cos square b as 1 minus sine square b minus cos square a will be written as 1 minus sine square a into we have sine square b. Expand the full bracket, so we will have sine square a minus sine square a sine square b minus here we will have sine square b and minus sine square b into minus sine square a, making it plus sine square a into sine square b. Now sine square b is getting cancelled, and ultimately the value of the full expression remains as sine square a minus sine square b. And that's the formula that you need to keep in mind, that sine of a plus b can be written as sine square a minus sine square b. Like I said, it's not exactly the formula it's not exactly the formula a plus b into a minus b is a square minus b square. That was only the first step in your simplification. But simplifying it further and further finally gave you this formula. So keep in mind that sine of a plus b into sine of a minus b is sine square a minus sine square b. Now in a similar way, if you try to derive an expression for yet another formula, yet another expression, then you will get something like this. The other expression that I am talking about is cos a plus b into cos a minus b. So what you can do with this is, again this is cos a cos b minus sin a sin b. I am using a shortcut here so that I can do it a little quickly. You can do it while you are practicing sums, but not in any of your college examinations, because this kind of terminology will not be acceptable in any of your written papers. Cos of a minus b, cos a cos b plus sin a sin b. Again this is of the type a minus b into a plus b. A minus b into a plus b will be a square minus b square. So a square means square of this, that is cos square a cos square b, minus b square means the square of this, that is sin square a sin square b. Now in this case we don't want everything in cos or everything in sin. If we are using cos a, then we will use sin b. So cos square a into Like I said, we need to use sine b. So we will rewrite cos square b as 1 minus sine square b. We are using cos square a, so we will rewrite sine square a as 1 minus cos square a. Expand the brackets, so we have cos square a minus cos square a sine square b. Expand the second bracket also, so we will have minus sine square b and plus it will be sine square b cos square a. So see, minus cos square a sine square b plus cos square a sine square b, both of them get cancelled, and we are ultimately left with cos square a minus sine square b as the final value for this second expression. So this will be cos square a minus sine square b. Now there's a little more simplification you can bring in this expression. That is, why write cos square a? We can also write sine square a if we want. And why write sine square b? We can also write cos square b. So if we write cos square a as 1 minus sine square a minus, write this as 1 minus cos square b. So you will have 1 minus sine square a minus 1 plus cos square b. So 1 minus 1 get cancelled. We are left with, I can say, cos square b minus sine square a. So this very expression, which was cos a plus b into cos a minus b, you can write it as cos square a minus sine square b, but you can also write it as cos square b minus sine square a. A good method to remember this expansion is that you remember that it doesn't matter in which sequence you are writing the angles, but the first thing that should come in front of you is cos square, and then it should be sine square. So cos a plus b into cos a minus b, that will be cos square minus sine square. Any angle can be written first and any angle later, just that cos square should come first and sine square should come later. And sine a plus b into sine a minus b will be written as sine square a minus sine square b, similar to a plus b into a minus b equal to a square minus b square, but not exactly that formula. So two more important variations or two more important results that you have learned from the expansion formula.